Okay, welcome to lesson 3, part 2. We're going to be taking a look at some word problems that are now requiring us to work backwards. Okay, so I'm going to show you what I mean by that. Example 3. What mass of aluminum hydroxide is dissolved in 350 milliliters of water if the pOH is 9.89? Okay, so whenever you're looking at a word problem, I highly recommend writing a reaction first. It kind of sets up what we need to find, what we're looking for, and how we can get there. So in this one, since we are working with a base, step 1 is going to be to write a dissociation reaction. So step 1, write a balanced reaction. A dissociation reaction is aluminum. Oh, that 3 should be on the outside of the brackets. Yes. Aluminum hydroxide dissociates to form aluminum ions, aqueous, plus 3 hydroxide ions. Now, from here, we want to grab important information. We're looking for mass. And they have given us pOH as a way to find the mass. Okay, so we're looking for mass, they've given us volume, and they've given us pOH. So let's go ahead and kind of identify some things that we can put on this reaction. We're looking for mass of this guy, our solute. Then from here, you're going to ask yourself, what connects me to my flow chart? Is it aluminum ions or hydroxide ions? I would have to say that our hydroxide ions connect us to the flow chart. If we are able to use the flow chart to get a concentration for hydroxide, then we can work it backwards to find our mass of solute. So step 2 is use flow chart. So we have pOH. It is 9.89. Fantastic. We're going to work that backwards to find our hydroxide concentration. To get there, you're going to go 10 to the power of negative 9.89. So 9, that's not what, let's clear that, 10 to the power of negative 9.89. Okay, so I get my hydroxide concentration, which is 1.28 times 10 to the negative 10 moles per liter. Hey, look, that's what we needed there. So I'm going to go ahead and now put this new information that we found under our reaction. 1.28 times 10 to the negative 10 moles per liter. So again, on paper, I am just writing a couple of significant digits there, but on my calculator, I have everything saved. All right, so now let's move into step 3. Step 3 is going to be find mass of unknown, which is, again, this guy here. So you're going to start off with what you know. 1.28 times 10 to the negative 10. And I'm going to actually write it as moles per liter because it makes unit analysis much easier. This is concentration. Concentration is a conversion unit. It's okay if it's written first. This is called a stoich statement. A stoich statement, the order particularly usually does not matter. However, I do like to have some order in writing the structure because it makes it easier to write. So this is my hydroxide concentration. Now, I need to convert this into moles. Remember, from now on, going forward, we are not going to write mole, we're not going to use our molar ratio until we're going moles to moles. So I need to convert this into moles before I can use my molar ratios. So I have 3 moles of hydroxide. Oh, sorry, that's not happening there. Okay, see what I mean? We first have to convert this into moles, and the way that we do that is by using our volume. We actually need to cancel out this liters. And the way that we do that is by using our 350 milliliters, which is the same as saying that we have 0.350 liters. The way I got that number is dividing our milliliters by 1,000. So I multiply by 305 liters. Liters cancels out. Now I have moles of hydroxide. Now that I have moles, I can use my molar ratio. I'm going to divide by 3 moles, okay, of hydroxide. Moles cancels out. Hydroxide cancels out. Let's finish our molar ratio. We have 1 mole of aluminum hydroxide, because again, ones are invisible in chemistry. And then lastly, now we have moles of aluminum hydroxide. How do we convert moles into mass? We have to use a conversion factor. That conversion factor is called molar mass. The molar mass of aluminum hydroxide is 78.01 grams per mole. Okay, so I'm going to go ahead and divide that number. So, sorry, multiply 78.01 grams, so 1, over moles. Moles cancels out. Now let's see what we're left with. And I recommend that you cancel out as you go along. You are left with grams of aluminum hydroxide. Perfect. Okay, so let's plug that into our calculator. So like I said, we're showing it on paper to have 3 significant digits, but in our calculator, we're going to use our full answer. So I'm going to go ahead, select. Actually, I'm not going to select. I'm going to go answer, second answer, times by 0.350, divided by 3, multiplied by 1, multiplied by 78.01. And there is our mass. So mass of aluminum hydroxide is equal to 1.17 times 10 to the negative 9 grams. There is your final answer. All right, next example. How many grams of magnesium hydroxide are dissolved in 400 milliliters of water if pH of the solution is 12.32? So first step, you're going to get real sick of me saying this, is you're going to write a balanced reaction. So magnesium hydroxide, that's a base, it's going to dissociate. Magnesium hydroxide. It's going to give me magnesium ions and 2 hydroxide ions. From here, let's go ahead and look at the information that's given to us. 400 milliliters. We're looking for mass. And it's given us a pH of 12.32. Now, you're going to ask yourself, actually, let's do a little bit of setup. We're looking for grams of this compound, magnesium hydroxide, and we have water, and you're going to ask yourself, what in this reaction is going to connect me to the flow chart? Again, it is going to be our hydroxide concentration. Connects to flow chart. So now we're going to go to our flow chart and actually find the hydroxide concentration. So step 2, the flow chart. Okay. So we have been given pH, and we need to get all the way over here to hydroxide. So I'm going to go down. We're going to have to find POH first, and then we're going to find hydroxide. The pH that they've given me is 12.32. 12.32. Okay, remember that this has two significant digits. To find POH, you're going to go 14 minus pH. 14 minus 12.32. 14 minus 12.32 gives me 1.68. So I get a POH of 1.68. Great, now let's find our hydroxide concentration, which is it's 10 to the power of negative 1.68. So 10 to the power of negative 1.68, which gives me a hydroxide concentration of 0.0289 moles per liter. Great, now we have something to put in our information here. So we found out that we have a concentration of 0.0289 moles per liter. Fantastic. Okay, then we're going to move into step 3, which is find mass of our unknown. So we're going to start off with what we know. 0.0289. Again, I'm going to write it as moles of hydroxide per liters. Then you want to cancel out the liters. We only want to have moles when we're converting using our molar ratio. So I'm going to use 400 milliliters, which is the same thing as saying 0.4 liters. So I'm going to multiply by 0.4 liters. Okay, and then I am going to cancel out the liters and I'm left with moles of the hydroxide. From there, you're going to use your mole ratio. 2 moles of hydroxide. And I have 2 moles of hydroxide and 1 mole of our unknown, which is magnesium hydroxide. Let's do some canceling out. Moles cancels out with moles. Hydroxide cancels out with hydroxide, and now I have moles of magnesium hydroxide, but we need to find grams. So again, if you have moles, you have grams, but you have to convert it, and you convert it by using your molar mass. Your molar mass of magnesium hydroxide is 74.33 grams per mole. So go ahead and use that. 74.33 grams per mole. Mole cancels out, and we are left with grams. We are left with grams of magnesium hydroxide. Okay, so let's plug that into our calculator. Taking our answer, multiplying by 0.4. 0, dividing by 2, multiplying by 1, times by 74.33. I get a mass of 0. We're going to round this guy to 2 significant digits. So mass of magnesium hydroxide is equal to 0.33 0.31 grams. Okay, we have a question here for you to try on your own. What is the pOH of a solution with 6.1 grams of a sulfuric acid dissolved in 300 milliliters of water? Okay. Pause the screen. You can go through the answer. Once you're ready, you can unpause and I'll have the full solution for you. Okay, let's walk through this. So first step, you write your balanced reaction, set up what's known, and then find the connecting piece to the flow chart, which is our H plus. Then you're going to find your H plus. Remember, if you find H plus, you're able to find hydronium. Here is my Stoich statement. Grams cancels out with grams, leaving me with moles. Then I use my molar ratio, which cancels out the sulfuric acid. Moles cancels out with moles, and I'm left with moles of my H plus. I then need to convert that into concentration, so I get my liters. Plug that into my calculator, and I get my H plus concentration. Again, I have left those ... just to show you that I haven't rounded at this point. You are then going to use the flow chart. Again, this concentration also represents my hydronium concentration. I take my hydronium concentration and convert it into pOH, and then I convert that into my pOH, which my final answer is 13.32. Okay, last example for the day. A 10 milliliter solution has a hydronium concentration of 4.02 times 10 to the negative 3 moles per liter and is diluted to 25 milliliters. So what you're doing is you're taking an acid and you're adding water to it. So if we're adding water to it, do we expect the pH to increase or decrease? Well, if we're adding water to it, it's obviously going to increase because it's going to approach neutral or get bigger. So it is going to increase, and I can show you this. So on my scale, 1, 14, 7. We are here in acidic region. If I add water to it, my acid is going to get weaker, which is going to move towards the basic or neutral region. So we're going to see an increase in the number. Now let's go ahead and calculate our pH beforehand and after the dilution. So pH before the dilution is equal to negative log of 4.02 times 10 to the negative 3, which gives me a pH of 2.40. Now, pH after requires a little bit more work. So pH after. I first need to find the hydronium concentration. We're going to use our formula C1V1 is equal to C2V2. C1 is equal to 4.02 times 10 to the negative 3 moles per liter. V1 is equal to 10 milliliters. C2 is our unknown. And V2 is 25 milliliters. So C2 is equal to C1V1 over V2. Let's plug those numbers in. 4.02 times 10 to the negative 3 multiplied by 10 milliliters. Sorry, that should have a capital M. Divided by 25 milliliters. C2 is equal to 0.00162 moles per liter. pH after is equal to negative log of 0.00162, which gives me 2.79. Okay, we can just go over this quickly, how to plug this into your calculator. Bracket 4.02 E. -3. Oh, we need the brackets. Bracket 4.02 second times 10 to the power of -3 times by 10 divided by 25. There is my answer right there. Oh, it should be 6.08. Then I am going to take this number and I'm going to convert it into pH. Negative log of my answer. 2.79. 2.79. So notice how our pH increased. Okay, and that is all.